I'm Anil Kumar, sharing with you a test question on vectors, and we'll also go through the concepts which you've learned in solving this question. That's the whole idea. It is to review what we have learned. Question here is a equals to 1 minus 2 minus 4 and b equals to 250. Calculate the dot product of 3a plus 2b dot 4a minus b. That's the question for you. Now, there are a couple of ways. In fact, I should say there are two ways to solve this particular question. If the question is as such, it may be simpler to find these combinations and then do the question. But if I add a part to this question, which is find angle between vectors A and B, right? So if I add this part, let's say this is A and this is B, in that case, it may be worthwhile to first find their angles and then go for the dot product. Let me explain you how. That's the whole idea, right? So we'll take our time to solve this question. Now, if I say that find the angle between A and B, then you have to find magnitudes of these two vectors. So let's say we have two parts to this question, right? So finding angle really means that we have this vector A, which is 1 minus 2 minus 4. Then what is the magnitude of this vector? Magnitude is 1 square plus minus 2 square plus minus 4 square. Well, we can always find this magnitude, which is 1 plus 4 plus 16, so it is 21, right? Okay, 16, 4, 21. Similarly, we can find magnitude of B. So we know vector B is equal to 2, 5, and 0. And since that is the case, the magnitude will be square root of 2 square plus 5 square plus 0 square. And that is 4 plus 25, which is 29 square root. So we get the magnitudes of these two vectors. Once you get the magnitudes, then it is easier to find the dot product. Okay, so let's write down the formula, which is A dot B is equals to magnitude of A times magnitude of B cos theta, and that gives you the angle theta as equal to A dot B divided by their magnitudes. Is that okay? So you could find the angle. So I wrote one question but solved the another one anyway. So let there be these part A and B genuine questions for you. Okay. So the angle theta is equals to A dot B, which is 1 minus 2 minus 4. I should say cos inverse. I forgot to write cos inverse here. Okay, so let me write cos theta now here. Okay, so theta is, let me write cos theta. Cos theta is A dot B, which is 2, 5, 0, divided by the magnitudes, which we worked out, square root of 21 times square root of 29, right? And this gives you, when you do the dot product, 1 times 2 is 2 minus 10, and that is 0, divided by square root of 21 times square root of 29, which is minus 8 over square root of their product. Okay, so let me just write down 21 times 29, 609. Okay, that's fine. So theta is cos inverse of this, right? So theta is cos inverse of this. Now, cos theta is even function, so we could write even 8 over square root of 609. Perfect. So this is, we are doing shift cos inverse within brackets 8 divided by square root of 609, okay, which is equal to 71, let's say 71 degrees, right? So we find the angle 71 degrees between these two vectors. So we did part B first. So the idea is, if this question would have been combined by part B, which was not when we started with, okay, in that case, the method adopted should have been, I'll now get back to this. I'll get back to the question now. Okay, that's fine. So we need to find the dot product of 3a plus, let's say, now we are solving part A. Okay, but I hope you've understood part B also, right? So part B we did first. Okay, so part A is 3 plus 2b dot 4a minus b, right? Now, what I was trying to say here is that to do this question, we could actually multiply. So we'll get terms like a square, b square, and all that. And then since we have done all that here, it becomes easier. So what I will do here is I'll kind of multiply. So I'll do 3a dot 4a will be 12a square, right? So magnitude a squared. Do you see that? This is their dot product. So let me write on the side. What is a dot a? A dot a is the magnitude of a. Let me write dot product in general. A dot b is, magnitude of a times magnitude of b cos of theta, right? So if theta here in this case is 0, then cos theta is 1. So it is magnitude of a square, right? So that's how we write it. So 3a dot 4a becomes 12a square, and then we have minus 3a dot b, and then we have 2b dot 4a, which is plus 8. You could write this as b dot a or a dot b minus 2 magnitude of b square. Now if you have done this part first, you have most of the values. Do you see that part? You know what a square is? So you can write this as 12, and a square is 21. So you can just replace this by 21. That is what I'm trying to say. The idea was this you could write here. So if you're doing both the parts, then this is a very, very effective method of doing, right? Now, a dot b also you calculated. A dot b you calculated minus 8. Do you see that? So what we found here was that a dot b, when you did this dot product right at the top, is minus 8. Do you see that? So we can use this value, a dot b, as minus 8. You can combine these two. So if you combine this, you could write this as, let me write this as plus 5a dot b. So we'll do it in the next step, minus 2. And square of this is 29. Do you see that, 29? So it becomes simpler. Are you getting my point? So it is 12 times 21 plus 5 times minus 8, which you found, perfect, times 2 times 29. So this dot product, instead of finding individually their sum and then doing the dot product, this is better. That's what I'm trying to say here, right? So let's figure out the answer. So 12 times 21 minus 5 times 8 plus, oh, that's also minus, I'm sorry. So we'll just delete this and do minus 2 times 29 equals to 154. So we get 154. Do you see that? So we get our answer. So in just 3 steps, and therefore we can write 3a plus 2b dot 4a minus b equals to 154, right? So that is the answer for this question. So I hope you understand how we can sometimes change our approach. We can do part B, where we actually evaluate everything required to solve for A and then solve A. So that's the strategy which we have learned in this question. I'm Anil Kumar, and I hope that really helps you. Thank you and all the best.